All right, welcome back. So in the main one, we have our tagless final style for the technical errors, and we have the hard-coded others for the business errors. In the main two, we went the full tagless final route, and we're saying that we're gonna have applicative errors and mono errors for handling all of the errors, technical and the business ones, and now we're gonna copy paste this again, same as we did in the previous video, and I'm gonna call this main 3. Okay, and I'm just gonna paste this, and we're gonna switch to running the third one, which is on this one. Okay, and basically this one is going to be very similar to the previous one. However, we're going to get all the ergonomics back. Okay, so it's going to be exactly the same, but we're going to get all the ergonomics back. And for this, we're going to use the mono transformer library. And by the way, one of the things that I forgot to mention about the in the previous video about one of the costs is that now we're dealing with mono transformers, and they have a tendency to be a little bit slower. However, most teams on this planet they actually have bigger issues than these performance issues. So if you do have performance issues, then make sure to benchmark your applications. And by the way, I didn't look at the bloop output, so we need to switch to 3 so that it actually does this. Okay, so we need to talk about MTL a little bit, and we're going to use a library called cats.MTL, which many people would argue is a misnomer. MTL stands for Mono Transformer Library, and it allows you to work with mono transformers without dealing with all of their issues, right? So basically, you have tagless final DSLs, tagless final DSLs and type classes for, that describe what a mono transformer would do. And so over here, instead of using the applicative error twice, we're going to use the applicative error for the technical errors, but we're going to use another type class from cats.MTL that would handle the business errors for us, but it's going to look pretty much the same, right? It's just that instead of raise error on applicative error, we're going to say raise on that thing that is going to come from cats.MTL. Okay, so just by having like 2 different names, we're not going to have any ambiguity, and we're going to get all of our ergonomics back. So let's start by adding cats.MTL to the dependencies. Where are our cats? Cats core, cats effect. Let's put it over here. Cats.MTL core, not now. Let me actually copy that, go to the build, do this, and do that, and have a comma over here. All right, so now we're actually going to import the build. We're going to go back to main 3. And the way this works is that cats.MTL has actually a more granular type classes. So an applicative error can both raise an error and also throw an error. So in cats.MTL you have ApplicativeHanddle, which similar to this one can do both. But we also have functor raise, which allows us just to raise. And ApplicativeHanddle extends functor raise. Okay, so for the error producer over here, we're going to say that our G is simply going to be an MTL functor raise, right? MTL functor raise like this. Okay, and let's actually remind this guy that it was actually changed. Okay, so we're going to use functor raise, and therefore over here, instead of raise error, we're just simply going to say raise, right? It's exactly the same thing, it's just called differently. Okay, just a different type class, therefore we're going to have a different name over here. Okay, this was pretty much it for this part. Over here in the error handler. So we're using a monad error for the technical error, and we're going to use ApplicativeHanddle from MTL for the other one. Applicative handle. Okay, not handler, handle. And if we jump in there, we're going to see that ApplicativeHanddle extends functor raise. Okay, so functor raise can only raise, and ApplicativeHanddle can both raise and handle. Okay, so first of all, we're getting all the ergonomics back. Okay, so we can go back to just saying DSL good, technical, and flat map console.good, like this. Okay, same thing over here. So we're going to say that this is going to be the bad bad technical, and therefore we can say dot handle error with, and all of that thing, whoops, all of that stuff goes away like this. All right, now pretty much the same thing below. Okay, we're just going to use not handle error with, we're going to use handle with. Okay, and that's all. So let's grab this one. Well, actually, let's grab this one. Let's grab this one, put it over here. So this is going to be the good business. Okay, good business. Okay, so now if we don't handle error with, it's going to compile, right? Because we also have the monad error for the technical error. However, over here, we're actually, well, we know the compiler doesn't know that in this particular case, we're going to produce business errors. And so if you wanted to handle the business errors, we need to call handle with, okay, handle with, like this. And by the way, it also has a method called handle, which is doing a similar thing. And there's actually a tiny issue with it, and I will show it to you later. Okay, so handle with wants a total function, and we need to, for this reason, we need to specify which errors we're going to handle. Okay, and therefore the handler code is going to be, we're just going to say, okay, business error, and then we're going to do console bad business error, like this. Okay. Handle with is not a member of type member f unit. Now this is probably happening because I forgot to import the implicits. So there's also cats.MTL implicits like this. Okay, let's see if it helped. Yes, it did. Great. So now let me copy paste this, copy, paste that. So this is the bad business error, and there we go. Okay, let me create a little bit more space so that we can have a look at all of the four. Okay, good technical, good business, and bad business. Okay, so they're all calling handle with. Okay, and now everything compiles and everything works exactly the same. There's still an either t below. It behaves exactly the same as before. Okay, let me show you handle real quick. Okay, so over here where we have the good business program. So the issue with handle is that, let me actually jump in there. So handle with actually wants a function from your error to an f of a. Okay, but handle just wants it to go to an a. Okay, which is why it's very, very dangerous. So let me actually show you what I mean. So if I just say handle, it's still going to compile, right? Because in our particular case, we're having a unit. And so we have a value discard over here. And in this particular case, we don't even see that the behavior is different because we're just printing it out. But actually, the behavior is a little bit different. And so for cases like this, I always recommend to use value discard compiler warning flag. So we're going to go and add it over here like this. Okay. Yes, please import the changes. Let's actually kill this guy. Let's close the handle for now. Let's close the dependencies. Let's close the build. We don't need this. In any case, so once it finishes and once it's going to start compiling this, it will tell us that we're discarding a value over here. Okay, yeah, discarded non-unit value right here. All right, and therefore we should always use handle error with. Okay, like this. And or is it just handle error? What was it? No, it was handle error with. It was correct. What does it say? Handle error with what? I cannot read this. Hold on. Does not take parameters. What? Yes, it does. Hold on. Oh, it's just handle with. Yeah. So this is the thing, right? So there's a bit of confusion because the handle error with actually comes from applicative, right? So this one, it comes from applicative. It's super confusing. Okay, so this one comes from applicative. This one comes from the applicative handle from mtl, and the same thing for raising, right? So raise arrow comes from applicative, and raise comes from the mtl. So now we have it. We got our ergonomics back. Okay, we still have like the same issues as before, but at least we got our ergonomics back. And in this particular case, we can actually even handle like all of the errors in the same chain. Okay, for example, if I grab this one, right? And I'm just gonna put it, I don't know, here, for example, right? So in this particular case, we're handling the business errors and we're handling the technical errors, all right? And yeah, so this is pretty much everything that I wanted to show you about this third encoding. And yeah, as I already mentioned in the previous video, there won't be like any opinions in this video. Okay, I'm just trying to be like as unbiased as possible. There's nothing wrong with the first solution. There's well, there are a lot of things that are wrong with the second solution. If you liked if you want to go the full Tagless Final route, I recommend this one. If you really don't want to forget to handle the business errors, then I recommend going with the first one. All right, now is the time for our final and the most exciting encoding, because we're going to use multifunctors. So let me copy this, create a new file, paste it, save it, main4.scala. What happened here? It should be just like this, main Scala. Okay, main 4 like this. What happened here? Do the other ones look fine? Yes, fine, fine, and fine. Okay, we have our main 4. Now for this one, we're going to use multifunctors. Remember that our f, it usually stands for, for half of a functor, right? Because it knows how to move the objects into some context f. Okay, now there are other functors out there, other functor hierarchies out there. There are bifunctors, the functors which have multiple slots, like this. This is a, bi stands for 2, trifunctors, and so on and so on and so on. So today we're going to use one of these, and for this we're going to use a library called Izumi, which is allegedly Japanese for spring. You can get it, the Spring framework. And what it does is it comes with a hierarchy similar to the cats hierarchy, but it comes with a hierarchy of bifunctors and trifunctors. And so the idea is that you will always, in your entire application, you will always, like all of your apps, they will have the second slot, and the second slot will be used for the error channel, right? So you always have this error channel. If your interpreter doesn't want to produce errors, it will just put nothing in there, and if it does, it will put in there what it wants to produce. Okay, so I'm gonna have the links down in the description for Izumi. Let me actually show it to you real quick, which is over here. If we scroll down over here, you're gonna see that this hierarchy is very, very similar to cats, right? So you have some sort of functor, you have some sort of applicative, you have some sort of a monad, you have errors, you have monad errors, blah blah blah. But they have, like, the versions was a 3. This is a trifunctor. It uses also the third slot for injecting something from the environment, right? So this is the typical reader T, either T stack, and we haven't been using the reader monad in the whole Tagless Final series, just because we didn't end up needing it. Okay, so we're also going to have an issue at the bottom where we're going to choose our effect type, because as of right now, all the effect types that we have seen, they have been working only with one slot. As of right now, Zio is the only one that can actually work with 2 slots, right? And we're going to use the Zio IO this time, and not the Zio task that we have been using in the previous video. Now, Izumi actually has an integration layer with cats. However, I didn't get it to work in the way that I wanted. I didn't manage to stick in the effect from the cats effect ecosystem. Okay, but it's not a big issue. There's nothing wrong with Zio. Okay, so let's just go and implement this whole thing, and then have a discussion about this. All right, so first of all, let me revert this. Let me go to the dependencies like this, and let me grab it from my script. Okay, so we're gonna add both the Zio and Izumi like this. So not now. So this is Zio 101, and this is Izumi. Okay, great. Let's go to the build like this, and let me put them in over here like this. We might have an issue with IO actually. Let me just do IO. Well, actually, let's see if it works. I don't care. All right, import the build, and let's see. Also, I'm just realizing, because now we're gonna have a version of a console that will have 2 slots, and if you remember in the previous video, we actually took the console out and we put it into this separate file. So what I'm going to do, I'm actually going to bring it back. So I'm going to copy that, and I'm going to delete this file. Yeah, so we have an issue, and we need to do IO over here because we have a name collision now. IO and like this. Okay, now that we're importing it explicitly, this will work. This part will work. All right, so I cut it out, and I'm gonna go to main 1, and I'm just gonna throw it in under here. Okay, like this, and I'm gonna go to main 2, do the same thing, just paste it back. Main 3, the same thing, paste it back. Main 4, the same thing, over here, paste it back, and even though we're going to change it right now in just a couple of seconds. All right, so let's switch to running the fourth one. Before we get there, I would like to mention that this is the first time that I was playing with Zio and with bifunctors and with Izumi, so take everything that I say with a grain of salt. For this one, we pretty much don't need any imports from the cats ecosystem. The only thing that we're going to need is we're going to use Scala util control non-fatal. We're not even going to use the chaining because we're not going to have stacked monods anymore, right? So we're not going to have monod transformers. This is actually one of the benefits, allegedly, that comes from these having separate slots, because now you don't need monod transformers, and therefore apparently it performs a little bit better. Okay, but I haven't done any benchmarks myself. Okay, so all we need to do, all we need to use is the non-fatal, and we're going to use import Izumi functional bio, right? Which stands for bifunctor IO, okay? And one of the cool things that we need to know about bio is that it has a thing called aff inside of it, okay? And if I jump in there, it's this weird looking thing. And the way bio is designed is that you don't even need this context applied plugin. You can simply use this app, which is simply a value, right? And you can call all the useful methods on it. So this is why this is pretty much the only import that we will need. We're going to start with 2 slots, and these 2 slots they're always covariant, and Visual Studio Code sometimes has these weird syntax rendering issues. So I'm just going to close it and reopen it, and therefore they're gone now. Okay, so we're going to have 2 slots, right? So the one on the left is going to be the one for the arrow, and these slots are always covariant. Okay, always covariant. Okay, so we're going to say, okay, so this is going to be a console for an app with 2 slots. And we're also going to have some type for the errors, and then we're going to say that both good and bad, they're going to produce on the left side this e, whatever it's going to be. Okay, so this is going to be our DSL. Okay, so now over here we're going to do the same trick, right? So we're going to say f plus over here plus underscore over here. We're not using the types from cats effect anymore, so we're using the types from Izumi, and the equivalent of sync is called bio, like this. Okay, and now it's going to produce a console of f, and this is the interesting part. Okay, so we sort of need to know ahead of time that we're going to deal with a functor hierarchy which has multifunctors, right, with the functors with multiple slots. However, we don't need to know ahead of time which errors we're going to produce. We just need to know that there will be an error channel, right? And so over here we're going to have an interpreter that will say that it will not produce any errors, right? It will say nothing. By the way, over here it feels like the error channel is now on the right, but notice there is a difference. Okay, so these are the things that are inside of the F, and therefore the error channel is on the left. This is the thing that is outside, right? So this is the console. It wants the F and it wants the nothing, so it kind of feels like the error channel is now on the right. No, it's not. The error channel is on the left. Okay, so it's going to produce a console with F and nothing over here. Okay, so the implementation is exactly the same. It's just that delay is called sync. Okay, so this is going to produce an F of nothing and unit, nothing, comma unit. Okay, like this. So now the whole thing compiles. As a reminder, this F does not come from context applied. It comes from Izumi, right? It comes from this thing. Okay, which is super cool. Okay, you don't need to remove the context applied plugin, because the way it works is that it just if it notices that there is already an F in scope, then it's not going to compile. Actually, let me show you this to you real quick. So if we have some sort of scope, okay, and we're going to have import cats over here, and we're going to have some method, def method for some F. Let's say it's going to need a functor, and it's going to get some F of int. Okay, and it's going to do an F of string, and we're going to do fmap F of a underscore dot to string. Okay, so this is the context applied. Okay, however, as soon as you have an F in the scope, for example over here, as soon as you have F int 1 to 3, then the context applied plugin is not going to generate this this object for you, and therefore it's going to say, hey, map is not a member of int. And this is exactly what's happening, right? Because at the very top we're importing bio, we're importing this F over here, this one over here, and therefore context applied simply doesn't generate anything for it. Okay, and also it has multiple slots. Maybe the context applied plugin doesn't know how to deal with these slots. Okay, great. The same deal over here. We're gonna have a covariant bifunctor. Okay, we're gonna have some sort of errors, and we're gonna say that over here, all of them. Whoops, the last one was incorrect. Over here, I'm going to produce some error. Now the interpreter can decide which errors it will produce. So it has the by the way, I kind of forgot to show you this in the previous video over here in the main, not in the previous video, in the previous example, because we went back to having like to having multiple to having different type classes over here. We actually can go back to using the context bound syntax, because if you look over here, we actually have a chance to not use the G at all. So for example, over here we can say colon, and I'm going to paste this. Our app is going to be simply a star which has a slot, and I'm going to have another colon, and we're going to paste this right here. So this is going to be just a star which has a slot, and therefore we don't need this implicit parameter list, and therefore because of the context apply plugin we can just simply use an F over here. And so now it looks like this, which looks kind of weird with 80 lines. In fact, let's actually go into the conf, and why does it have a rendering issue over here? Let's have a max column of 100. Max column of 100 like this, so that this one doesn't look so ugly like this. Yeah, this looks a little bit better. Let's do this for the other one real quick. Over here, where is it? Over here. Let's just copy that like this, and we can say that this is a star. I simply just remembered the context applied plugin, and then we have star with a slot. Now we can remove this, and now we don't even need to use G if we're using it anywhere. No, we're not. Okay, great. Right, so let's go over here, and yeah. So when I looked at this, I realized that this is what was happening. Okay, so over here we're gonna have multiple slots, right? Multiple slots like this, and we're going to need a bio error, which is an equivalent of an applicative error. So this is the only thing that we need. We actually don't need these guys. Okay, and now this is going to be an error producer of some f. Okay, and the error channel, remember over here we need to say what the error is going to be. We sort of have an issue over here because now we have to declare all the errors that we're going to produce, and we're going to produce both the technical errors and the business errors. Well, technically or, right? But that's not the point. The point is that we need to use an anonymous ADT for it, which in Scala 2 is either. However, in Scala 3, we're going to have union types, and this is going to look way better. Okay, so we're going to say that on the error side, we're going to produce either a technical error or a business error. Right? So usually when you're dealing with eithers, you have like a good value on the right and a bad value on the left. In this particular case, we have bad values on both sides. Okay, so we're going to have a, we're just going to copy this probably. Yeah, we're just going to copy this, going to have a comma over here, paste over here. We're actually going to go to all of these f of n's, and we're going to paste them over here. We're going to improve this a little bit in just a second. Okay, so now notice that this part already compiles, right? So we're doing like f.pure. However, as a reminder, this is not context applied anymore. Okay, this is the you know, the f that comes from Izumi, and it simply has a pure as well. Okay, like this. Okay, so over here, instead of raise error, we're simply going to say fail. And because we said, you know, we're failing with an either, we need to wrap this one into a left. Right, so this is going to be a left because this is a technical error. Okay, and over here we're simply going to do f.fail like this, and because this is a business error and the business errors are on the right over here, we're simply going to do a right like this. All right, cool. Now the whole thing compiles. As a reminder, like in Scala 3, it's going to be way more awesome because we will be able to say f of a technical error or a business error, and it's better because over here we wouldn't need to do this. Right, we will just be able to do this, and it will just figure this out. Okay, let me go back to this. All right, great. So let's go to the error handler, which is over here. Same deal as always. We're gonna have two slots. Both of them are covariant, and we're gonna deal with some sort of error. And over here, it's pretty much the same as before. Error unit. Okay. Now over here, we're gonna have well, first of all, same as before, we're going to have two slots. Okay, and for this one, instead of using BIO error, we're going to use BIO monad error, right, which is equivalent to monad error. So the BIO error, okay, so let's do from the beginning. So BIO is the same as sync, well, equivalent to sync. A BIO error is an equivalent to applicative error, and BIO monad error is equivalent to the monad error. Okay, so we still need these guys, but over here, this is very, very interesting, so pay attention. Over here, we're going to say, sure, the interpreters, they have all the power. They can decide what they throw, what they don't throw, okay? However, over here, we're able to constrain the interpreter a little bit. We can say, sure, you can write any interpreter you want, but the one that you will be able to inject over here is going to be the one that on the error channel has, you know, this typical either, right? Okay, business error. Okay, which is really, really cool because over here we can say, hey, you know, you can write an interpreter for a console that might, you know, throw exceptions or whatever, but you're not going to be able to inject it over here because over here I want the one that as the error channel uses a nothing. Okay, which is super awesome, right? So you can say, hey, if there are any errors in the console, please handle them for me before you even get here. Okay, which is really, really awesome. Okay, so we don't need these implicits anymore. Okay, so we're going to produce an error handler of f, and let me just copy this. F, comma, this, comma, this. Okay, therefore over here, every time we say f of unit, we're gonna do this and just do that. Okay, great. So the good technical program simply stays the same as before. Okay, the bad technical problem stays very, very similar. It's just that instead of handle error with, we're going to do catch sum, right? And there's also catch all, and it's a similar, you know, the existivity thing. Okay, so we're going to say catch sum, and because like the technical errors are on the left, we need to not forget to wrap it into the either left. Okay, so we're pattern matching on the left, right? Super similar. DSL over here. Okay, so in the good business program, we're simply going to say catch sum, the same as we're doing over here, catch sum. Okay, but now we need to make sure that we're catching the right, you know, and the same deal over here. So we're gonna say catch sum business error. Okay, and notice that you can, like in this catch sum, you can handle both the business errors and the technical errors, right? So yeah, so this is pretty much the whole thing. So now all we need to do is we need to inject some effect type that has 2 slots, and the one that we're going to use is going to be ZIO. Okay, so remove this one. It's going to be ZIO, and on the right side, as always, maybe I even have it, yeah, like this. Okay, great. So the way we run ZIO programs is by doing this. We're going to import ZIO runtime. Default, I'm going to call it runtime. Okay, I just want to do, like, you know, runtime stuff. There's a dot over here. Okay, like this. Great. So now let's actually, what should we do? Maybe mark dot value like this. Remove. Okay, and go over here and do something like runtime unsafe run, open the curly brace, remove it, and put it over here like this. There we go. And as you can see, the behavior is exactly the same. So let's go and look at it a little bit more slowly now that everything compiles, and now that I can you know, jump into things and so on. Okay, so okay, over here we have a console. It wants an f with 2 slots, and it uses a second parameter, which you don't really need to, but I prefer to do it like this because over here, this way I have the ability to constrain what errors the interpreters will produce. Okay, and we're saying, okay, so we're producing a good, we're producing a bad, and they will have this E on the left side. This is the implementation. Uses a version of sync, right? So now it says instead of f delay, it says f sync. Okay, but pretty much everything is, the rest is the same. It's just that we're using this nothing over here by, you know, we're saying that we're not going to produce any errors. Okay. Error producer, same thing, 2 slots, and there's a dedicated tab for the errors. This is the implementation. We're going to use BIO error, which is a similar thing to an applicative error. We're saying that this interpreter will produce these kinds of errors. This code is pretty much equivalent to what we had before. Pure for the good values, fail for the bad values. It's just that because the fails are others, we need to specify, are we doing the left one or are we doing the right one? Same thing for the error handler. The implementation uses the monad error, BIO monad error. Okay, and it says that it will only work was the DSLs for the error producer that produced these kinds of errors, and only work with the DSLs for the console that produce only these kinds of errors, which is nothing. Okay, and the implementation over here is the same as before. You know, you have catch sum, catch sum, catch sum. If you use catch all, you will get an exhaustivity check like this. Why are we not getting an exhaustivity check? Catch all. That's interesting. I thought we would. Probably the same deal as before because the throwables are not an ADT, but the either is an ADT. Hold on. If we go into bad technical, produce error. Interesting. I was hoping that we would get it over here as well. In any case, like this. All right, we're using catch sums, we're using ZIO IO, and by the way, let me jump in there. So these are just a bunch of type aliases, right? So ZIO is a trifunctor. It has something for the environment. It says, you know, you can inject anything you like. This is what you're going to use for the errors, and this is what you're going to use for the value. In the Tagless Final series, we were using the task, which was basically saying that the error channel is going to be fixed to a throwable. Okay, and there are a couple of others, right? But they all just type aliases for ZIO. All right, yeah, so this is pretty much it. I want to show you one really cool thing that you know, because all of these bifunctors, they're covariant. You can actually do something really cool. You can go to the error producer over here, right, into the implementation. You can say, hey, listen, over here, I'm actually not producing any of that. And because this slot is covariant, you can say, hey, I'm actually not producing any errors. Now, it doesn't do, you know, too much good in the usage, because in the usage you're never seeing this type. You're always seeing you're never seeing like this anonymous class type, right? So good technical over here, right? If I do this, it still shows me the one defined in the trait, right? And so you don't really see this. However, when you're inspecting the implementation, right, imagine that this implementation would have been like, I don't know, 20 lines long, you would see right away that it doesn't produce any errors. Over here, you can be a bit more explicit. You can say, hey, I'm actually only producing the left side. Over here, I'm not producing only anything, and over here, I'm producing only the right side. The more intriguing thing is in the error handler, okay? Because now we can say, hey, sure, you can give me an error producer that will produce any sort of errors, but I'm going to make sure to handle all of them, right? So over here, I'm going to say, hey, I'm going to handle all of them, right? And now the compiler will have you back. It's going to say, hey, you said that you're going to handle all of them, but you're not handling all of them, okay? And so what you can do is you can go over here and you can say catch all, okay? And over here we have our typical either, so we can fold. And notice that in this fold we're gonna do bad on both sides, right? Because we have technical errors over here, we have business errors over here, and we have the good values over here. Okay, so now the compiler made sure that you actually did what you said you would do. You know, you said that you would handle all the errors, and now you did. Okay, and now I can pretty much do the same trick everywhere, right? So I can over here in all of these places, I can say that this is going to be nothing, right? And over here, it's going to force me to handle all of them. So I'm just going to do catch all over here, catch all over here, and I'm going to do catch all over here. And now I can say over here that we're actually producing an error handler that actually handles all of the errors, like this. Okay, and now at the bottom, when we're injecting it, we're seeing that we actually have a program that does not produce any errors because all of the errors were already handled. Okay, and I find this really cool. Yeah, so let me have an empty line over here. And there we go. This is how I'm going to commit it. I'm going to clean it up and I'm going to commit it, but I'm going to leave this catch all thing. All right, so now it seems like we can have our cake and eat it too, right? We have the full tagless final route. We're giving the power to the interpreters. For example, over here we're saying, hey, if you need it, you have a dedicated error slot, and feel free to specify it over here. By the way, again, like this part is super optional, right? You could have had like this E over here, for example, right? Or you could hard code it, right? But if you hard code it, then you might as well just use either. Okay, so in the DSL you're seeing, hey, there will be some sort of error, right? Because there is always this dedicated error channel, right? And the interpreter can still decide if it's actually going to produce an error or not. In this particular case, the console interpreter decided, hey, there won't be any errors. Okay, So it kind of feels like you can have your cake and eat it too. What's the catch? Well, the catch is that from the very beginning, you kind of sort of need to know ahead of time, right, that you're going to use this particular functor hierarchy, the hierarchy that allows you to have, multiple slots. Okay, this is sort of like the only catch. Also, it's the more parametricity you have in the code, uh, the easier it is to reason about for experienced developers, but the harder it is to learn for beginners. Like if a beginner looks at a code like this, at these like smiley looking types, emoji looking types, then yeah, it's kind of a lot to process. However, you do get allegedly you get some performance benefits because now you're not dealing with mono transformers, right? With MTL, you were getting like sort of the syntax back, the ergonomics back, but you're still dealing with a mono transformer stack. Over here, allegedly, you don't, and because you always have like dedicated channels instead of like wrapping things. I believe this is called effect rotation, whoever coined the term, and yeah, so this is a really sexy solution. The only downside, you kind of need to know ahead of time that you're going to use a hierarchy with 2 slots. Right, so before I go, let's have a quick recap. So it is important to have distinct error channels for business errors and technical errors. The technical errors are the one that you usually can't really handle. You pretty much just log them at the end of the line. And the business errors you actually want to handle because your HTTP library will have no idea how to handle your business errors. Okay, with the very first solution, and again, there is nothing really nothing wrong about it. You're hard coding the business errors, and therefore you cannot forget to handle them. But then you're forced to handle them always. With the second solution, you're using the Tagless Final style for the technical errors, and you're using the where is it? Error producer. Where's the trait? It's over here. Why is it over there? With the Tagless Final, you're still having like 2 distinct error channels, but now you can forget to handle your business errors. It's usually not a big deal if you forget to handle your technical errors because usually your HTTP library would handle it for you, or some other thing that is in front, right? It's just gonna log them. But if you forget to handle the business errors, it's usually a big deal. So it's not super ideal to be able to forget to handle the business errors. Okay, with this solution we used the applicative error twice, and so we lost a little bit of ergonomics. With cats.MTL we got the ergonomics back because we were simply using distinct type classes for this. For the technical errors we were using the applicative error, and for the business errors we were using functor raise. Okay, and was the fourth one where we went like completely off the rails, and we used bifunctors with Izumi and BIO, and it feels like this is the superior solution. However, like as already said, if you already have a Tagless Final code base, you would need to pretty much go and rewrite the whole thing. It would be a mechanical rewrite, but still, it's kind of a lot, and it's probably a little bit harder to learn. But let's be honest, not much harder. All right, so I'm going to clean this up and I'm going to push this to GitHub so that you can have a look at it at your own pace. And yeah. For now, as always, it's been Vlad, devinside.com. Don't forget to like this video if you did. Subscribe if you want to improve the developer inside you. And if you learned something today, consider supporting me on Patreon or on GitHub sponsors, whatever you prefer. And just watch my videos weeks and sometimes even months before everyone else. And most importantly, take care.